So there are many types of applications that use the law of signs. We've already looked at one application where a surveyor might use it when we were trying to find out how far across it was a bridge. You see it in engineering, astronomy, and navigation. So in this particular example, what we're looking at are two fire lookout stations. And I put a picture over here of Mother Neff State Park here in the state of Texas, where they have one of these fire lookout stations actually there at the park. And what they had happen in this particular example we're looking at is we have two fire stations and they spot the fire on the mountain. And you're given the bearing from station A to the fire and from station B to the fire, and you're asked to find to the nearest tenth how far is the fire then from station A. So what are we given? Although we're looking at the diagram here, let me make the diagram just a little clearer. So when they give us the bearing from station A to the fire is what's read as 50 degrees east of north. So if station A is right here and they told me that I'm 50 degrees east of north, so I would be on the right hand side, right, because that's east of this north-south line, that's the bearing up to the top of the mountain. And what we know is if we were to draw a triangle like this, which would connect station A, station B, and the fire, we have a triangle. And when we have a triangle, we have interior angles that we're technically interested in. So if I know based on the bearing that this outside angle is 50 and the north-south line has to be perpendicular to the horizon, which is what this shows here, then I can tell by that the interior angle of my triangle here has to be 40, because 40 plus 50 is obviously 90. Now we can do that same process over here on for station B. Station B was given as having a bearing to the fire of 36 degrees west of north. So again, if this is the north-south line, 36 degrees west of that line leaves me 54 degrees inside of the triangle. Okay, so now we have some information then for our triangle we can use. I have an angle here of 54 degrees. I have an angle over here of 40 degrees. And then I'm also told in this example that the two fire stations are 20 miles apart. So that's the information that I'm given, and I now have to be able to apply what I know to find out what the distance is, in other words, from the lookout station A up to the fire. So since that is considered side B across from angle B, then we are going to use the ratios as follows. So I know angle B and I know angle A, and I need to find out how much is angle C. Well, angle C would be 180 minus 54 minus 40, giving me 86 degrees. I know what side C is, and I can use that ratio to then find out this missing information. So we have side C over the sine of 86 equals side B over the sine of angle B, which is 54. Solving for B, we have 20 times the sine of 54 divided by the sine of 86, and then rounding to the nearest tenth, I find that it is 16.2 miles then from station A all the way up to where the fire is at. So it's just kind of an interesting scenario where we might have the fire stations and trying to figure out the distance, and in also using navigation, using the law of signs.